guys, welcome to Bar Z. My name's Stan, and today we're here with Pat from TRAK Machine Tools, and we got kind of a surprise for you. We're going to do a plant tour. I thank you for letting me come in and poke around.
Glad to have you here.
Okay, they are a new sponsor for the bash, and my first reaction when I first walked in is, gee, I never heard of you guys. Can you give me some background on the company?
Certainly can. Unfortunately, we still get that a lot, not as much as we used to.
Okay.
And it's probably because of the fact that our product is designed for the CNC world where people are doing non-production machining. And because most people, especially because of the skill level that's available nowadays, tend to kind of head towards the production machining because it's easier to do with cheaper labor and things like that, right? And so we're still making a product that's really best designed to work with a skilled machinist that knows what he's doing, but we make the product where you still retain all the manual capability. You can program at the control in English and geometry prompts, and it usually takes a couple of minutes. You're all cutting chips.
So prototype, short run, thing like that.
Fixtures, tooling,
Yeah.
all of that.
Oh, beautiful, beautiful. All right, let's get to it.
All right, sounds great, thanks. Built the circuit boards here, pretty much everything except for the box that all the parts are in. So all these fine people are our experts, and they build everything that we need to go inside of the ProtoTRAK when we build it, okay? We do everything on a Kanban system here, so as you can see, every box in here is labeled, and therefore when somebody runs out of parts to make and they need their next job, they can visually come up and see where there's a need, such as that box that's upside down. All the instructions with quantities and components are on there, so they can just go and pick the next thing that's needed and start to make that part. Okay? So our managers don't actually have to assign jobs to people. Our managers worry about bigger issues. And then as you can see in the different areas here, we're just making the different components. We don't make the motors, okay? We purchase the motors, but we make the encoders, and we make the driver boards that control the encoder and the motor board's position. And so you'll see along with that, back in this corner, you'll see that we have our system here for building the circuit boards. So we've actually got a machine here that will bring the circuit board in. We can have all the components on little reels, and it'll lay down a layer of flux and then pick and place all the components, run through the oven. They'll come out completely soldered. We also have another soldering machine back in the corner here that does some special components there. And of course, there are a few components that are too large to use in this system. So these people at these tables here will actually manually still do soldering of some of the parts that go onto the boards. But there was a time when all this stuff was done on the outside. Now that we can do it ourselves, we can make the boards faster than we can make the rest of the product. So we'll run for a while, and then we actually get a little break for a while. Because none of our products are obsolete. What we do is we have an express exchange program, which basically means that no matter how old the product is, you call into service, figure out what component has failed in what module, and then we'll actually be able to go and get that module, send it out to the customer. He can plug and play, get up and running right away. He sends the old one back in. We refurbish it in that department. It goes back into the inventory. So if you bought a ProtoTRAK in 1985, we got every part that makes it run.
Nice.
Okay, so this is just shipping and inventory for the most part. But all the shelves you see on the left side of shipping, that's all the parts for every component, for every machine we've made since like the mid-80s. Okay, so therefore we're able to keep every product we've ever made up and running all the time. On this side, it's really just inventory parts for the parts we're about to build, or some of the assemblies after they're completed. Okay? In our machine shop, we use a lot of our own products and a few of others. You'll see the Mazak turning centers over here, and we've got a big Mazak milling machine over here. But all of our turning centers are here and our mills over there, and then all the rest of these products can be moved around to create a cell around the operator when he's making parts. So he's actually getting a completed part in every cycle. Therefore, if we run into something that's incorrect, we can stop right away and correct the process, not have a whole bunch of rehab to do at a later point. Okay? And so, in this case right here, you'll also see that we have our engineering machine shop over here. These are our two top paid guys that work directly for engineering. They make all of our tooling, all of our prototypes, all of our fixturing for our parts to be used in production. So here we're doing what a ProtoTRAK really designed for, which is making maybe one part at a time, but as quick and as efficiently as we possibly can. Okay? So as you'll notice when you come into a department like here, each of our cells has two machining centers, And then in a lot of cases, this TRAK 2-op, which is a product we make for secondary operations, can be moved around with a pallet jack. So therefore, if he's got more operations than what he can do in the primary machine, then they'll go in the 2-op and he'll run this inside of the cycle of the big machines, right? So if that's making a part in 20 minutes and he's got a job that has to be done in 5, instead of putting 2 operations in that machine and running one every 25 minutes, he's getting one completed every 20 minutes.
Sounds pretty lean to me.
Right, exactly. And there's sometimes the guys will run as many as 4 machines at the same time, depending on what it is.
Yep.
The other thing that we do to be efficient, because we know that labor is the most expensive part of what you have in your parts, we'll actually have sometimes running a completely different primary job in one of the other machines while the other job is running, okay? So some of our parts that we make might have 4 operations, others are just a single operation, so we put it in whichever machine is the case. Kind of tend to sort of move the machines around about every other day, except for obviously the big ones. Okay? Shipping department, and because we're close to the harbor, it's common for a container to show up. We'll stop what we're doing, unload it right away. All of our iron comes in like what you're seeing here. So the iron comes in from Taiwan with the motor and the spindle intact, and then nothing else is here. There's no screws, there's no brackets, there's no CNC components to it. Just what it takes to run the spindle and turn it on is all that's in here when we get it. Okay, all of them are made to our specifications, and we use 4 different companies, like I said, because they all specialize in certain types of iron. And we keep a lot of inventory around here because the bank doesn't give us much on our own money anyway, so we would rather have what we need when the time comes and the customer places an order. When the machines are finished, they go back out there to that final door out there where they get wrapped up and greased up, and then the truck comes around, picks them up, and they're on their way. Okay, now because you're local, all the machines that are sold around here are picked up by a rigger and put right in place, but anywhere else we'll use a shipping company to send them across the country.
Mm-hmm.
All right? Throughout that 4-day or so time schedule, once it's completed, then the shipping guys will come pick it up, wrap it up, and send it out the door. And these cells are actually set up where, as you can tell here, we're building all the lathes, and over here we're building all the milling machines. And this one's kind of a wild card where if for some reason we're upside down and we got a lot more of mills than lathes or vice versa, this here the guys can build either one. So we have some guys that are specialized for one machine or another. We have some that are specialized to know how to build everything that we make. All right? And so as you can see, this rack here has all the components to turn the machine from what we receive from Taiwan into a finished product. And once it's pulled, this comes in. The guys know exactly what to do with every component on here, how to put it on, assemble it all, get it up, test it, and put it out the door. We also have a teaching department over here because all of the guys that fix our machines out in the field have to go through multiple weeks of training on and off all the time. And so over here we've got some of the machines that are either built just for testing and repairing. We tear them apart, put them back together, so on and so forth, so that everybody knows how to run them and fix them correctly. And then anywhere we can find some spare space, we keep inventory. So see a little bit of that too. This machine right here is just a larger version of the small machines you've already seen. And we don't have enough room to put it in the showroom, so it's out here. Our machining center is also out here, but because we got a little construction going on, it's a little...
Oh, I'm not done with this thing yet.
That's okay.
I didn't even see this one on the way in.
Yeah.
I don't know how I didn't see it, but...
It's a big monster.
Oh, it's...
Well, you know what happens when you make a really cool product that works really well? Somebody needs a bigger one. So this is what we call a TRAK LPM, which is short for low production machining. It's designed to do quantities of probably 100 parts or less But when you've got a high mix, low volume of piece parts, that's where this comes into play. You'll notice in here that we've got a Kerrigan's ball lock system in here where the vice plates are. And so we can actually have different fixtures for different jobs, and then when we have to change over from one to another, we can literally just pull out the ball locks, pull this fixture out, put the next one in, pull your program in, tell it where the tools are in the tool changer, and be up and running. We can do most changeovers in about 15 minutes. Talked a little bit about is that 2-op. So every one of these 2-ops actually comes with a special pallet jack, so you can pick it up and move it wherever you need to. And if you look at it from the inside, it's kind of hard to tell, but back there behind that door is an 8-position tool changer. So it'll actually do full production 3-axis machining, although it's designed mostly for secondary operations. There's a lot of people out there that make small parts, and they really like how quiet they are when they're running in their garages. Here's the electronic hand wheels. They're not connected to the carriage, right? And so they're, like you said, fly-by-wire. When I move it, it moves, and I can change from find a course for how fast they react, okay? And so that gets me around in the part really quickly and gives you a better idea of how you're actually maneuvering with the electronic hand wheels, okay? That being said, besides the fact that they'll do that, they also give you some features that would be very difficult. On a manual lathe, for instance, I have to have the ability to have a compound so that I can cut an angle or something like that, right? In here we have a feature that we call do one. And in the do one, we have the ability to cut any taper, any radius, or any fillet. So for instance, even though I'm not going to actually cut this, I'll show you how it works. I would place my tool where I need to be to cut a chamfer. I would select taper, then it assumes 45 degrees. I could change that to any angle. But when I hit the set key, what's going to happen is I turn either one of these hand wheels and it cuts at a 45-degree angle. See that? When I go back in the opposite direction, it'll automatically disconnect the hand wheel where I started, so that it doesn't gouge a previous radius or diameter that I was already cutting at, right? If I push return in here, you'll also notice that it works the same way with a fillet or a radius. I just tell it what size radius. When I turn, I get 90 degrees of angle right there. Both directions, it disconnects the handle at both sides so it won't gouge. Okay, so that replaces the compound. Also notice there's a really cool one in here that people always ask about. See, that says thread repair, right? What that actually does is walk me through a process where I can pick up an existing thread from something that was made at a previous time and recut that thread. So if I'm in a job shop or something like that where somebody brings in a part where they broke the screw and they gotta have it welded and repaired, I can literally pick that tool, that thread right back up and cut it again and have a completed part after the weld. Okay, there's also a feature in here that we call go to, and go to is simply an electronic stop that when I program in there a certain number, each time I get to that number, it'll stop moving. So to give you an idea here, I'm just going to go and put in here that the Z-axis is going to stop at -2 inches. Okay, and what's going to happen is whether I'm dialing with the hand wheel or the joystick, when I get to -2, it disconnects the hand wheel. So therefore, I don't have to watch the DRO when I'm trying to cut to a certain number. I simply plug in that number and just machine away and watch how my chips fly. And all this stuff is just done in the manual mode. We haven't even gotten to the simplicity of how it is when you actually program it yet.
Nice.
Okay?
Okay.
Now, I put a simple program in here, but I haven't physically set it up correctly yet, okay? So you'll get a good idea on how it works, but I want you to just see what a program looks like in here, right? So I'm going to go to the program mode and go to the beginning. And in here we have an event we call a cycle. And what a cycle does is it actually puts together all of your information on how you want to rough, how you want to finish, how much material you want to remove, how much you want to leave, so on and so forth. So you'll see through here, I'm starting at 0, 0. I have a depth of cut of 50 thousandths. I'm cutting, doing the roughing with the Z-axis, right? I've got my feeds and speeds, which can be programmed either in surface footage and thousandths per rev or in RPM and inches per minute. I've got my tool number that I'm going to use, what I want to leave for my finish cuts. This one's for my diameter, this one's for the faces, and then my feeds and speeds for my finish cut alone. After that, the program works like this. It's just point-to-point machining, right? So it says, okay, from 0, 0, I'm going to go to 3/4 of an inch in 0, and I'm going to blend a little 100 thousandths chamfer at the end, right? The next piece, I'm going to keep the x-axis the same, but move the z-axis to -937. And the next piece, I'm going to actually cut a taper. And all I'm doing is going point to point. So what you're going to see when I push this button that says look is what I actually programmed here,
Oh,
right?
that's the
Now, while
profile.
you were talking to me in a minute, I did all that in the background while you weren't even watching me. And it took me almost 45 seconds. Okay, so you'll see here, here's my first move with my chamfer, my second move across, my angle here with a radius in here, another move out here with a chamfer, and then come out to the total size. These dotted lines are depicting where my material is now so that it knows how to machine it, right? So once I do that, the next thing I do is I go to my setup mode and I set my tool setup. And in here, you'll see that my tool number 1, I'm just going to go to edit so you can see what I did. It basically says, okay, take your tool, take a cut, measure, and tell me what you just cut. And then face off the end of the part, tell me that's Z0, and tell me the radius of the tool so I can incorporate it into all of my arcs and angles and things like that. So once I've done that and completed it, then the next thing I would do is set a reference position and say, where do I want to go for tool changes? Let's just put this at a 6 and 6. So I'm far enough away that I can get my hands in there and change my tools, right? Last thing it's going to show me, if I go to tool path, it's going to show me all those little cuts in there that I just told it to do. So it's going to wrap it in here and it's going to cut away all this material and then come back and finish it. All right, now there's one other feature in here that I think you'll really like. It's what we call verify part. And in verify part, I can define the stock that I actually have. And then when I'm done with that, when I go to make part here and I push verify part, you're actually going to watch a simulation in a solid model of everything I just told it to do for me. And there's your completed part. So by now I should feel really confident that this thing's going to do what I want it to do.
Press the go button.
You would hope so, right? You ready to push the go button? So in here, I'm just going to make a simple program to give you an idea. So I'm going to go to the beginning. I'm going to tell it I want to make a pocket, and I'm going to tell it it's a circle. Okay? The information that it needs to make the circle, I'm just going to call 0, 0 the center. I'm going to use a rapid plane of 50 thousandths above, and I'm going to go 1/4 of an inch deep. Okay? I'm going to do this on a 1-inch radius. I want a climb mill, so I'm going to tell it I want to cut counterclockwise by pushing number 2. I'm going to do it in 2 passes in the Z. I'm going to use a zigzag way of getting into the material, so push 1. For a finish cut, I'm just going to leave 10 thousandths for the final pass around the outside. I'm going to put in my RPM here, just put it at 2,000 for both my rough and my finish. Whoops, missed one there, 2,000. And then my plunge feed rate, my machining feed rate, and my finish feed rate with my tool number. So when I finish that and I push this button that says look, you're going to see a circle is all. Right? Next thing I'm going to do is I'm going to set up my tools, and I'm going to keep this real simple. I don't know if there's a reference position set right now. There isn't, so I'm going to jog it up a little bit. Just give myself a little clearance and set that for my home. I'm going to go to the tool table, and in here I'm just going to set my tool and tell it that it's a 1/2 inch end mill, like so. And here's my end mill information. And that's going to allow me to check my tool path, which as you can tell from a top view, it's just going to spiral out from the center to cut the part. Right? The other feature, like the lathe, has verification where I can actually see what it is that I'm going to do in a simulation, and there you go. All right, I didn't determine the size of the stock, so it machined just about everything away, but that's okay. I can control that. And then last but not least, the last thing that I have to do is switch to the manual mode, and in here, I'm just going to tell it where my zero is. Now, for sake of demonstration, I'm going to do this with my calibrated eyeball.
Oh, now these are your wheel by wires.
That's correct. What we call tracking or electronic hand wheels. That's exactly.
Well, I love the way they're angled, and it's so ergonomic. You stand right in between them and work left and right.
You know what's funny is we invented this first for the lathes, and then when we got to the first really big mill, we realized the average guy didn't have long enough arms.
I do stretch on mine
Right.
from time to time.
So that kind of fixes that. So all I'm going to do here is I'm going to use the quill because it interacts with the actual z-axis too, right? And I'm just going to set a 0, 0, 0 point right here. So I'm just going to say X is at absolute, Y is at absolute, Z is at absolute. See that? Mm-hmm. Once I do that, because the machine knows whether the head moves or the quill moves, I'm just going to put the head up and lock it.
Oh.
So now I'm going to switch modes and I'm going to go to the run mode. And in the run mode, I can start at the beginning, I can start anywhere inside, or I have a trial run where it'll run without moving the Z just to show where it's going to go. In this case, I'm going to start at the beginning, and before I push go, like I showed you on the lathe, I eliminate the fear factor by using the tracking feature.
Well, that would be good for not machining into those jaws, and yeah, I can think of a bunch of reasons to use the fear factor.
Yeah, if nothing else, just not having to explain that to your boss why you did it in the first place, right? So in this case, when I push go, right, I'm actually going to become the feed rate. So you notice I turn the handle a little bit. It says, hey, make sure you put the first tool in there. It tells me what it is. Then it tells me to start the spindles. I'm going to reach up above you here for a second.
All right.
Start the spindle. And when I push go this time, instead of actually going, it's just going to set the RPM to what I programmed. And now as I turn the hand wheel, it's actually going to physically make the part the way I determined. So the first thing that allows me to do is get really close to the part and make sure that what I see here better be what I see there. If not, I made a mistake in my setup, right? Once I get to that point, I'll usually switch to the opposite hand wheel because it's 4 times slower than this one, and I'm going to let it actually do what it's doing. So you're going to see here it's going to start to ramp into the part, right? And then once it gets there, it's going to start the outside circle. See that? So when I know that it's doing what I need it to do, I can simply say stop, CNC run, and go, and let it make cuts. I can control the amount of step over that it has, and I didn't check it before I did that, so it's at a pretty fine amount of step over. I can cut it a lot heavier if I wanted to. And when it gets out to the final rough cut of the first cut, it'll lift up, come back, and go down and do the second cut just like you would expect. last 10,000.
Cool. So if anyone wants to get a hold of you, what's the website?
It is www.trak, TRAK, like machine tools.com.
And best bet is for them to just call in and talk to a knowledgeable salesperson.
That's correct. Usually you'll talk to our sales support team and they'll figure out which sales guy is in your area and have him contact you, whatever method you want to use.
Hey Pat, thanks for showing me around out there. I hope you guys enjoyed the tour as much as I did. I got, this is probably going to be cut down to maybe a 25-minute video, so they're not going to see near as much as what I saw, but it was incredible out there, and I really, really appreciate you taking the time. You guys have got a surprise for us coming up at the bash too, don't you?
That's correct. We actually have a mobile demo truck, which is a small panel truck that has one of our milling machines and lathes inside of it, along with a compressor and a generator, so that we can pull it up in front of anybody's shop and fire it up and show them how our stuff works. We find that because we're here in beautiful Los Angeles, where it takes 3 hours to go 3 miles, it really makes sense that somebody doesn't necessarily want to waste a whole day to come and see our product. So now we can bring it to them, and in this case, we're going to bring it to your show. And so you'll be, as you saw, you're going to see everything there and how it runs.
Nice, nice. Well, you guys are going to be able to go out, get in the truck, ask questions, see the machines run. Can we cut parts?
I think we can.
You guys are going to be able to watch them cut parts, and that is just incredible. And we sure appreciate you guys taking the time and effort to bring your stuff out to the bash. And I want to thank everyone for watching. We'll see you in June, and we'll see you when hell freezes over.